So this is a graph of the cosine function. And in blue, you have the line y equals 1/2. So if I find the intersection of the two curves, I'm going to find the values of x by looking at the x-coordinates where the cosine value is equal to 1/2. So I'll show you an example here. If I look at this point here, that's minus 7 pi over 3.5. So that means that at minus 7 pi over 3, the cosine is 1/2. Same thing here. Of course, there's another point there, another one here, another one here, another one here, another one here. As you can see, there are going to be infinitely many points, okay, of intersection of these two curves, and infinitely many angles where the cosine is 1/2. So in this section, we're going to solve trigonometric equations, but not so surprisingly, since those trig functions are periodic, there are going to be often like infinitely many solutions. Sometimes we're going to want to restrict our solutions to a certain interval. So for example, here, if I wanted to only keep the angles between 0 and 2 pi, where the cosine is 1/2, I would disregard this one, this one, this one, this one, all the other ones, except the two that are in between 0 and 2 pi, which are pi over 3 and 5 pi over 3. So sometimes we'll restrict the interval where we want to have our solutions. So coming back to our problem, I want to solve cos of theta equals 1/2. We saw there were going to be many solutions. So how do we get those solutions, and how do we write all of them? Okay. So first of all, we're going to collect the solutions in the interval 0 to pi. So if you think about the unit circle, for the cos of theta to be 1/2, it means that if I have a point on the x-coordinate on the unit circle, its x-coordinate is 1/2. Okay, and that angle here would be an angle where the cosine is 1/2. So that's going to occur where? Well, that occurs for an angle of pi over 3. In which case the y-coordinate, which would be the sine value, is √3 over 2. So that's one possibility. There's another one, which is if we end up here at 1/2 minus √3 over 2. Now that occurs either, I could say minus pi over 3, it would also, if I want to have an angle between 0 and 2 pi, it occurs at, so this is 2 pi minus pi over 3, so that's, right, so this is 2 pi, a full term, but remove pi over 3, so that's 6 pi over 3 minus pi over 3, that's 5 pi over 3. Like that. So I have those two angles in the interval 0 to pi, and now, so maybe I'll write those down. So theta could be pi over 3, or theta could be 5 pi over 3. Okay. And if with pi over 3, okay, let me choose a different color here. If I add a full turn to that, so if I keep rotating by 2 pi again, I will again end up with an angle. So it's going to be 2 pi plus pi over 3, an angle where the cosine is 1/2. So I could technically add 2 pi to that and get another angle. And I could rotate once more, okay, rotate twice. So if I add 4 pi, it's also an angle that works. That means that the cosine is again 1/2 there. So in other words, as long as I had a multiple of 2 pi, I'm going to have a valid angle. So usually we write pi over 3 plus a multiple of 2 pi. 2 pi k, where k is any integer. So z here stands for the set of integers. So plus or minus 1, plus or minus 2, plus or minus, well, actually even you could include 0. So 0 plus or minus, so this at 0 plus or minus 1 plus or minus 2 plus or minus 3, and so on and so on. Okay, so if k is 0, you get pi over 3. If k is 1, you get pi over 3 plus 2 pi. If k is minus 1, you actually rotate but clockwise, so it's pi over 3 minus 2 pi, and that again will be an angle that's coterminal with pi over 3, so therefore it's going to have the same cosine value. So the same goes here. If we add 2 pi k, we're going to get a collection of angles where the cosine's a half. So the answer would be all these angles here. Okay. So I'll show you another example. Now we're going to solve 2 sine theta minus 4 equals minus 5. Okay, but this time we'll restrict the interval where we want our angles. So it's all the angles between minus 2 pi and 2 pi. So first of all, solving for sine of theta. So we get 2 sine theta is minus 1. So solving for sine of theta, we get sine of theta is minus 1/2. So we're interested in angles where the sine is minus 1/2. So let's think about this for a second. So we're going to again find the angles between 0 and 2 pi, and then probably we're going to be subtracting 2 pi's from those to get the all the angles we want in the given interval. So sine is minus 1/2. So sine is the y-coordinate. So the y-coordinate is going to have to be negative. So we're going to be either, hang on, minus 1/2. We are going to be, let me redraw this. This is 1, remember? So minus 1/2, we are here or here. So what are those angles? Where there's this one. What is that angle? So this, if the y-coordinate is minus 1/2, the x-coordinate is minus here √3/2. And this one would be √3/2 and minus 1/2. So this occurs when, so maybe maybe it's easier here to look at a corresponding angle, so a reference angle. So here, this point here, right there, if I just reflect it across the origin, that's 1/2 √3/2. Oh, sorry, it's not. I wrote them down in the reverse order. So it's √3/2, 1/2. So the cosine is √3/2, and sine is 1/2. So that occurs at pi over 6. So this is pi over 6 right there. So this angle I'm looking at, this one, the big one here, that's pi plus an extra pi over 6. So that's 6 pi over 6 plus pi over 6. That's 7 pi over 6. So 7 pi over 6 is one angle. Now this angle, okay, again here we're going to be short of pi over 6 for a full turn. So it's going to be 2 pi minus pi over 6. So that's 12 pi over 6 minus pi over 6. So that angle is 11 pi over 6. Okay, so those are the two angles. And then from this I can add or subtract 2 pi. If I add 2 pi, I'm going to get an angle that's beyond 2 pi. So I need to subtract 2 pi from those to get all my possible angles. So theta is, let me write them down, element of what? Well, there's 7 pi over 6, from which we're going to subtract 2 pi. There's 11 pi over 6, from which we're going to subtract 2 pi. Okay, and there's 7 pi over 6 and 11 pi over 6. So those will be our 4 angles. So maybe I went too quick here, but without restrictions, okay, the answers would have been 7 pi over 6 plus 2k pi. But you have to realize, okay, what are the values of k that I can, so there's clearly k equals 0, but what are the values for k would give me an angle that's between 0 and 2 pi. So if k is 1, I'm adding 2 pi, so clearly I'm going to be above 2 pi. And the only possibility is just to subtract 2 pi, so make k equals -1. So this is what I've done here, right? This is when k is -1. Okay. And if k is -2, it's going to be too small. It's going to be below -2 pi. So those are our angles. So maybe let's compute those. So 7 pi over 6 minus 12 pi over 6, that's -5 pi over 6. 11 pi over 6 minus 12 pi over 6, that's minus pi over 6. 7 pi over 6 and 11 pi over 6. So those are our four possible angles.